How do you get the dream concrete? It's simple. You ask for what you want and you make sure you get it. My name's Tyler Lay. I am a concrete freak, and thank you, concrete dreamers, for tuning in this video. Make sure you subscribe before you leave. I'm gonna be talking about what is the dream today. It's really about what is it do you want in your concrete mixture. Well, we want concrete that is tailored to the environment and the application. What am I talking about? Well, if you're in a desert, you're gonna need a different set of concretes than if you're in blizzard snow country, or if you're in a place where it floods and rains a whole lot. Each one of these needs a concrete tailored for that environment. We need concrete, though, that can perform whatever we throw at it for more than 100 years with minimal repair. Ladies and gentlemen, that is amazing. So what am I talking about? Is this a dream? No. This is PEM. What? What is PEM? PEM means performance engineered mixtures. Performance engineered concrete mixtures. It's concrete mixtures that are engineered to perform no matter what the application. And there's a document out there, AASHTO R101, that tells you exactly how to do this. And you'll notice if you read the title, it has the word pavement in it. But don't be scared off by that, because it doesn't have to be for pavements. It can be used for anything with just a few slight tweaks. There's been a whole bunch of people that have been involved in this. Amazing, amazing, great team, and a bunch of industry partners and state DOTs that have been involved as well. So it's been a massive, massive team. And we got together and we figured out PEM is truly about two things. It's about deciding what you need, and then it's about using better tests to get better answers. I'm gonna make lots of videos about this, but this one's just gonna tell you about what is it do we need. So how do we currently test our concrete though? Simply, we usually use something called slump, that's on the left here, something called strength, where we break cylinders or possibly cubes, depending on where you're at in the world, or you'll use something called an air meter where you measure the air content. Slump, strength, and air. But do you know when these tests were developed? 1918, 1836, in the spring chicken of the bunch, 1949, about 70 years old or so. That is the most recent test that we use every single day to test our concrete. So why in the world should we change away from these tests? Well, our concrete in the last 70 years has changed immensely. So why the heck are our tests still exactly the same? That doesn't make any sense, right? Shouldn't we fix this? Well, the current tests don't really measure what matters. So what does matter? Well, we actually got together with a whole bunch of experts for 2 days, battling it out, talking about it, deciding what is it specifically do people need to make Dreamcrete, right? The greatest concrete you could ever dream about. And we came down to some very simple categories. These. You need to know the workability. You need to get that right. The permeability, the shrinkage, cold weather resistance, aggregate durability, and strength. You might say, whoa, I don't need cold weather resistance because I'm in some place that's very, very hot, like Florida, or maybe some places in Texas. Great, then just don't use it. You just pick out the things that you need and you leave the others behind. But a lot of concrete, the majority of it, you can get it right if you nail these. You can get the dream to get these right. So let's talk about each one of them. Workability. Well, we don't want our concrete to be too wet, and we don't want our concrete to be too dry, but this should be largely chosen by the contractor. They should pick what kind of concrete that they're gonna place. Then for permeability or fluid penetration, this is a big deal because the longer we can keep fluid out of our concrete, the longer that life of that concrete will be. So this is one of the secrets. Pretty much every durability mechanism involves some kind of penetration of an outside fluid. Let's talk about shrinkage. Shrinkage is when concrete moves and sometimes can cause itself to crack. Here's an example here. It's no good. We want to minimize that. And there's also something called curling or warping, depending on how you want to define it. It just means the concrete moves and causes itself to be loaded in weird ways and cracks. What am I talking about? Here's concrete that's placed on top of soil, could be a pavement, could be a slab on grade, and that concrete may dry at the surface, and when it does, it will shrink at the surface compared to the bottom, and that will cause it to curl upwards. And if it's loaded on the edges, that will cause cracking. Oh man, we don't want that. We want to stop it. Well, if we can control our shrinkage, we can control this. There's cold weather resistance. This is pretty simple. There's two different mechanisms. One of them is freeze thaw damage. That's when concrete has water sitting on it. Then it becomes critically saturated. And then once a freezing cycle happens, it becomes damaged. Oh, we want to avoid that. That's not good. And there's another thing called calcium oxychloride attack. Now I'm showing a picture here of them dumping an immense amount of de-icer salts on the concrete. And that's what happens. When we de-ice our concrete a lot, we can get this thing called calcium oxychloride attack. And what it is that first your concrete starts to shade or shadow around the joints because the joints hold all of those de-icer salts right up against the concrete. And then if you were to zoom into those joints and look inside, they're actually deteriorating. They're wallowing out from the inside out. See, it's being eaten there. That's not good because eventually you get this big, huge gouge. You have to come back in and repair it. It's horrible. We want to avoid that. There's a thing called aggregate durability. Your aggregates can sometimes have problems. There's two basic mechanisms. One of them is alkali-silk reaction. Looks things like this. I've got videos about it where concrete expands from the inside out and causes itself to crack. And there's decracking. That's when you have aggregate that don't perform well in freezing and thawing environments. When they get, again, saturated and they freeze, they cause cracking. The final thing we got to make sure we get right is strength. You're like, whoa, strength? I thought strength is the most important thing. No, we actually thought it was the least important thing. We always find ways to get strength, and all these other things are largely more important than strength. But strength is still essential, but otherwise unimportant. We need concrete that's strong enough, and extra strength is not needed. We don't need anything extra than what we ask for. Actually, extra strength can cause us a lot of problems. So who in the world is using PEM, this new concept, this new way to get the Dreamcrete, right? Well, about 20 different organizations are right now inside the United States. They've been doing projects with them. They've been trying it out. They've been making it their own, and that's the key. But the leader is New York DOT. They have been leading the pack. They have specifications in place where they're doing this every single day. It's like that New York state of mind, baby. So in summary, if you want to get yourself the Dreamcrete, this is the way to make it happen. I'll be making several more videos about this to give you some more of the details. So if you are not a subscriber to my channel, please like this video, subscribe to this video, leave me a comment below. And of course, check me out on Facebook and Instagram at concrete.tyler. Take care, my concrete dreamers, and I'll see you real soon with another video.